Hi everyone. Today I will talk about ABG interpretation in a very simplified way for the sake of MCQ practice only, MCQ solve only. So let's start. So basically, before actual ABG interpretation, we have to know three to four basic things. Very first of all, that we have to know normal values of three things. Okay, normal value of pH, normal value of carbon dioxide, and normal value of HCO3 minus or bicarbonate. Okay. For the sake of ABG interpretation, we have to take these values as a single normal value. Though these parameters are always expressed in a range in our body. So the normal single value of pH will be 7.4, PCO2 will be 40, and bicarbonate will be 24. So you can remember this very simply as all of them has 4, 4 and 4. Okay. So first thing is this. Second thing is that if any primary problem is with PCO2, then it will be called as respiratory, as carbon dioxide is handled by lungs. And any primary problem of bicarbonate, it will be called as metabolic, as bicarbonate is handled primarily by kidneys. Okay. Third basic thing is that CO2 itself means H plus. That means increase in PCO2 means increase in H plus, and decrease in PCO2 means decrease in H plus. Okay. CO2 carbon dioxide itself means H plus, or the hydrogen ion. Okay. This is the third basic thing. And the fourth basic thing is compensation. Compensation, how this works, that if the primary problem is with the respiratory system, the metabolic system will come to compensate, and vice versa. So always the opposite system will come to compensate the primary problem. Okay, this is the basic thing you have to remember. Now comes actual interpretation. Okay, so during interpretation of a ABG, the very first step will be to look at pH. Step 1 will be look at pH. Okay, if the pH is less than 7.4, it will be called as acidosis, and if the pH is more than 7.4, it will be called as alkalosis. This is a very simple chemistry from our childhood, we all know that. Then step 2 will be look at PCO2 and bicarbonate, and look which value, PCO2 value or bicarbonate value, which value is favoring the pH value. That means, suppose pH value has came as less than 7.4, that means it is acidosis. Now how acidosis can occur? Acidosis, the term acidosis means excess of acid in our blood. So this can happen only if the acid is in excess or the base is in deficit, isn't it? So it can be that increase H plus or increase acid itself means acidosis. That also means increase in PCO2. And if this happens, so it will be called as respiratory acidosis, as the primary problem is in CO2. And if there is pH, the pH is less than 7.4 and the base is deficit, that means the HCO3 is decreased, then it will be called as metabolic acidosis. As bicarbonate means metabolic, we have already talked that the bicarbonate, any change in bicarbonate, it will be called as metabolic. So if the pH comes as less than 7.4, that means it is acidosis. Acidosis means either the acid is more or the base is less. So if the acid is more or the PCO2 is more, it will be called as respiratory acidosis. If the base is less, it will be called as metabolic acidosis. Now if the pH is more than 7.4, that means it is alkalosis. Now alkalosis means the base is more in the blood. Alkalosis, the term means. So it can occur if the base is more in blood or the acid is less in blood. So it can occur if H plus is decreased, that means PCO2 is decreased, then it will be called as respiratory alkalosis. And if alkalosis happens due to excess of bicarbonate, it will be called as metabolic alkalosis. Okay, fine. Now after the primary diagnosis of respiratory acidosis, metabolic acidosis, respiratory alkalosis or metabolic alkalosis, these four, we have to know a concept that is called as anion gap. AG, anion gap. The formula of anion gap will be sodium minus bicarbonate plus chloride. Simple formula, you have to remember this. And the normal value, the normal value of anion gap will be 12 plus minus 2. You have to remember this, 12 plus minus 2. So the concept of anion gap will only come if the diagnosis is metabolic acidosis. Metabolic acidosis, if my diagnosis is metabolic acidosis, then only I will calculate anion gap. If my diagnosis is any other than metabolic acidosis, the concept of anion gap will not come. So only in case of metabolic acidosis will calculate anion gap. So if the anion gap is normal, so it will be called as nagma, that is normal anion gap metabolic acidosis. And if the anion gap is high, it will be called as high anion gap metabolic acidosis or hagma. Okay, so now normal anion gap metabolic acidosis can occur due to two causes, simply two causes. One, it can be due to GI loss or it can be due to renal loss. Okay, if it is due to GI loss, the two conditions includes VIPoma, where there is a tumor that is secreting VIP in very much excess, or second, it will be ureterosigmoidostomy. Renal loss includes only one condition, that is RTA or renal tubular acidosis. Okay, now comes the example of high anemia metabolic acidosis. So there is a very simple mnemonic for that. The mnemonic goes KUSMAL, kusmal. So K means ketoacidosis. Okay, ketoacidosis. Ketoacidosis, example of ketoacidosis are diabetic ketoacidosis, starvation, alcohol intake in excess, and second U means uremia. S means salicylate poisoning. Salicylate poisoning, salicylate means aspirin. Aspirin poisoning can also mentioned in the question. Third will be fourth, basically fourth will be methanol. Fifth will be alcohol in general. Alcohol in general, that also includes ethylene glycol also. Alcohol, this alcohol also include ethylene glycol. And L means lactic acidosis. So these are the conditions where high anion gap metabolic acidosis will occur. So the mnemonic is very simple, kusmal. Okay, now comes the concept of compensation. So first of all, we will take metabolic acidosis. So in metabolic acidosis, what is the primary problem? The primary problem is decreased in bicarbonate, isn't it? Decreased in bicarbonate. If the base is less in amount, it will be acidosis. And as the primary problem is with bicarbonate, it will be called as metabolic. So in metabolic acidosis, the primary problem is bicarbonate. So as we talked earlier, in this case, the compensation will be from the respiratory system. The respiratory system will try to decrease PCO2 also, because as the base is less, respiratory system will try to decrease the carbon dioxide or the H plus to maintain the balance. So the this will be the compensatory change. Okay, So how much will be the compensatory change in every decrease of 1 unit bicarbonate? The decrease of PCO2 will be 1.2. Okay, the decrease of PCO2 will be 1.2. And in case of metabolic alkalosis, the primary problem is increase in bicarbonate. Okay, and the compensation will come from respiratory system only. So the compensation will be by increasing PCO2. Okay, so in this case, every increase of 1 unit bicarbonate, the PCO2 will increase by 0.7. Okay, PCO2 will increase by 0.7. So if in case of metabolic acidosis, in every unit decrease of bicarbonate, if the PCO2 decrease by 1.2, then only it will be called as a fully compensated metabolic acidosis, and same goes for alkalosis. If this much PCO2 compensation does not occur or occurs but less in amount, then it will be called as partially compensated metabolic acidosis or metabolic alkalosis. Okay, now comes the compensation of respiratory acidosis. Okay, this is second. Third comes respiratory acidosis. So in respiratory acidosis, the primary problem is increase PCO2. Increase PCO2. So the compensation will come from the metabolic part. So as a part of compensation, the bicarbonate will also increase. Bicarbonate will increase. Now, in case of respiratory system, there is again two things, that is acute and chronic. That is acute compensation and chronic compensation. So in case of respiratory acidosis, for every increase of every 10 unit of PCO2, if the bicarbonate increases by 1 unit, it will be called as acute respiratory acidosis. And increase of 10 unit of PCO2, if the bicarbonate increases by 4 unit, it will be called as chronic respiratory acidosis. Now comes fourth, respiratory alkalosis. In case of respiratory alkalosis, the primary problem is decrease in PCO2. Decrease in PCO2. So the compensation will come from kidney. So as a compensation, the bicarbonate will also decrease. So in this case, every decrease of 10 unit of PCO2, if the bicarbonate decreases by 2 unit, bicarbonate decrease, okay, it will be called as acute respiratory alkalosis. Okay, and if in every decrease of 10 unit of PCO2, if the decrease of bicarbonate is 4, then it will be called as chronic respiratory alkalosis. So this is the compensation, and you have to calculate this compensation. And in case of respiratory acidosis or alkalosis, the acute or chronic thing will come. And in case of metabolic alkalosis or acidosis, you have to calculate the compensation, and you have to tell whether it is non-compensated or partially or fully compensated. Okay, now we'll see one example. Here the pH is 7.35, the PCO2 is 40, and the bicarbonate is 16. So the very first step is to look at pH. By looking at pH, we can say that it is a case of acidosis. Uh, Now the PCO2 value is still normal, but the bicarbonate value has decreased. That means it is a case of metabolic acidosis. Okay, now whether it is compensated or partially compensated or it is uncompensated, the compensation, if it happens, it should come from PCO2 part. PCO2, as the primary problem is metabolic acidosis, the compensation will come from the opposite uh, end, that is PCO2. As there is no change in PCO2, we can say it is an uncompensated metabolic acidosis. Okay,